All right, let's kick things off. Today we're doing a deep dive into EnerVerse,
EnerVerse.
which is this new framework for robotic manipulation.
Mm-hmm.
And it's really been generating a lot of buzz.
Yeah.
The research paper published January 1st, 2025,
Very recent.
very, very recent, by researchers from Agibot and Shanghai AI Lab.
Uh-huh.
And it details how EnerVerse allows robots to basically predict the future
Yeah.
in order to plan their actions better. And we've got
It's wild.
Yeah, we've got some interesting stuff to unpack here. Free anchor view,
Mm-hmm.
robots learning from video games, a data flywheel effect.
Yeah, what is going on here?
What is going on here?
So I think the core issue is this.
Mhm.
For a robot to successfully manipulate objects in the real world,
Right.
it needs to understand what will happen next.
Like it needs to have some foresight.
Exactly. And existing approaches, they kind of struggle in
Yeah.
these complex dynamic situations.
Right.
So that's where EnerVerse comes in.
This sounds like it could be a real game changer.
Yeah.
So what makes EnerVerse so different?
So EnerVerse has three key components.
Okay.
The first one is it uses chunkwise autoregressive generation.
Okay.
So instead of predicting every single moment,
Mm-hmm.
the AI predicts chunks of future frames.
So like it's seeing
Like watching a sped up movie.
a sped movie of what's about to happen.
Yeah, exactly.
Okay, so the robot's getting a glimpse into the future,
Yeah.
but in a more manageable way.
A more digestible way.
Okay, what's next?
Okay, so the second component
Right.
is called free anchor view, or FAV space.
FAV space.
Think of it as being able to place virtual cameras anywhere
Oh, okay.
to get the best possible view for the robot.
Interesting.
This is really helpful when you're dealing with occlusion,
Mhm.
where objects might be hidden from view.
Right, so not just one view, but like a whole network of viewpoints,
Oh, never.
giving it a more complete picture.
Yeah.
Okay, interesting. And what about the third component?
So the third component is a data engine pipeline. It combines AI and 4D Gaussian splatting
Wow.
to create incredibly realistic simulated data.
Huh.
And this is really important because training robots in the real world
Mm-hmm.
is expensive and time consuming.
Yeah, it makes sense to train them in a virtual world first.
Exactly.
So is that how they kind of address this gap between simulation and reality?
That's exactly right. So the AI generates these multi-view videos
Uh-huh.
in the simulation, and then 4DGS
Mm-hmm.
creates a detailed 3D reconstruction.
So they're building like a digital twin of a real world environment.
Basically, and here's the really clever part.
Okay.
This 3D reconstruction is then fed back
Mhm.
into the AI model,
Okay.
which leads to the generation of even better videos.
So the simulated world is becoming more accurate.
Yeah,
And then in turn, the AI models are becoming more sophisticated.
exactly. It's a self-improving loop.
The self-fulfilling prophecy.
Yeah.
This reminds me of like language models predicting the next word you type.
Mm-hmm.
Is there a connection there?
You're on the right track.
Okay.
So EnerVerse, it takes inspiration from language models,
Okay.
but it adapts that concept to the visual world.
So instead of words, it's predicting images.
Yeah,
Essentially anticipating what will happen next, but visually.
exactly.
Okay, that's pretty remarkable.
Yeah, that's pretty cool.
So the robot can learn from these simulations as if it were experiencing the real world.
Yeah, that's the idea, and it goes even further.
Okay.
EnerVerse can actually generate an end-of-sequence frame,
What does that mean?
meaning it knows when the task is complete.
So it's not just seeing into the future,
Right.
but it's also understanding the goal of the task.
Exactly.
Okay. So what does this actually look like in practice?
So the research paper highlights a couple of examples.
Okay.
One is a robot placing blocks precisely into a foam work table,
Okay.
which sounds simple, but it's
Yeah.
actually quite tricky
Yeah, I imagine so.
because it requires fine motor control,
Mm-hmm.
and the foam and blocks look visually similar.
Right. So EnerVerse is helping the robot differentiate
Yeah.
between the objects in the environment.
Exactly.
Okay. What other tasks are mentioned?
Another example is sorting transparent objects,
Oh, wow.
which is difficult even for humans.
Yeah. Transparent objects, they're hard to perceive.
Right, you can't see their boundaries.
Yeah. How does it handle that?
So the researchers found that EnerVerse
Mm-hmm.
enabled the robot to handle these transparent objects
Successfully.
successfully.
Wow. Okay. So these examples really show how EnerVerse could change how robots are used
Yeah,
in various industries.
absolutely.
Are there any other notable details from this research paper that we should touch on?
I think one of the things they emphasize is the importance of FAVs.
Okay, the free anchor view.
The free anchor views we were talking about earlier,
Yeah,
they provide a much richer understanding of the 3D environment,
makes sense.
like having multiple security cameras covering different angles.
So multiple perspectives instead of just one fixed view.
Exactly.
Yeah, that makes sense for these complex tasks that involve manipulation.
It's all about providing the robot with the most comprehensive visual information possible.
Absolutely. All right, this has been a fascinating look at EnerVerse so far.
Yeah.
Clearly, this is a significant step forward in robotics.
I think so.
And we're only just beginning to explore its potential, so we'll dive deeper into some of these concepts in the next part of our deep dive.
Sounds good. So we've been talking about the potential of EnerVerse, and I think a really critical aspect of it is how it addresses the challenge of training data.
Yeah, you're referring to that self-improving data loop that we touched on earlier.
Right.
Can you unpack that a little bit more?
Sure. So training robots in real-world settings, it's not only costly, but it's also logistically complex.
Right.
It's hard to do.
Yeah.
So the data engine within EnerVerse kind of tackles this issue head on.
And it all starts with simulated environments, if I'm remembering correctly.
Yeah, so the AI model first generates these multi-view videos within this virtual world, and then 4D Gaussian Splatting creates this highly detailed 3D reconstruction based on these videos.
So they're essentially building like a digital twin of a real-world environment.
Exactly.
Okay.
And here's the really clever part. This 3D reconstruction is then fed back into the AI model.
Okay.
Which leads to the generation of even more realistic and intricate videos.
So it's a continuous cycle of refinement.
Exactly. It's a loop.
The simulated world becomes more accurate, and in turn, the AI models become more sophisticated.
Right. It's a self-fulfilling prophecy.
Yeah.
And this process really significantly reduces the dependence on real-world training data.
Okay.
Which makes the development cycle more efficient and cost-effective.
It makes sense. And the research paper mentions real-world testing of EnerVerse.
Right.
What were some of the specific applications that they explored?
Yeah, so one example was a robot tasked with placing blocks accurately into a foam work table.
Okay. Sounds simple.
It sounds simple, but it's actually quite challenging.
Yeah, I can imagine the precise placement required.
The precise placement, and then also the fact that the foam and the blocks visually look very similar.
Right. So EnerVerse is helping the robot to not only understand the future, but also to differentiate between these like subtle visual cues.
Exactly.
Right.
So EnerVerse allows the robot to kind of navigate that task with accuracy and finesse.
Okay. Were there any other examples that demonstrated the capabilities of this framework?
Yeah, another one was sorting transparent objects, which is something that even humans often find tricky.
Yeah, because transparency makes it hard to perceive the boundaries and the shapes of those objects.
Yeah.
So it makes manipulation very difficult.
Yeah. How do you even grasp it?
Right.
So the researchers found that EnerVerse enabled the robot to handle these transparent objects effectively.
Wow.
Which really showcases its ability to perceive and interact with these challenging visual scenarios.
So the applications in like manufacturing and logistics are pretty clear.
Yeah, absolutely.
But let's shift gears for a moment. We briefly mentioned the link between EnerVerse and language models.
Right.
Can you elaborate on that a little bit more?
Sure. So at its core, EnerVerse borrows this principle of prediction from language models.
Okay.
So language models predict the next word you'll type.
Right.
Based on patterns and relationships in text data.
Yeah.
EnerVerse applies that concept to the visual world.
Okay.
So it predicts the next visual state based on the preceding ones.
So instead of words, it's predicting images, essentially. It's anticipating what will happen next, but visually.
Right. And this ability to anticipate those visual changes is really what allows these robots to plan actions more intelligently and adapt to these dynamic situations.
So it seems like this research is kind of blurring the lines between different fields of AI, highlighting this convergence of concepts.
It's very interdisciplinary.
Yeah, and the researchers point out that EnerVerse doesn't just generate like an endless stream of future predictions.
Right.
It also has this clear understanding of the task's objective.
Yeah.
We briefly discussed that end-of-sequence frame.
Right.
What are the implications of that capability?
So the ability to generate that end-of-sequence frame, it really demonstrates that the robot doesn't just see the future. It also understands the goal of the task.
Okay.
And can determine when that goal has been achieved.
So it's a level of comprehension that goes beyond simple automation.
Right.
It suggests the robot possesses a degree of understanding
about
the purpose of its actions.
It understands the why.
This is an important distinction.
Yes, definitely.
Yeah. This deep dive into EnerVerse is giving us a lot to think about.
It is.
The potential applications are vast.
Yeah,
And it seems like we're entering a new era of human-robot collaboration.
for sure.
We've really explored the technical intricacies of EnerVerse
Yeah.
and its potential to, revolutionize robotics. And it's clear that this framework goes beyond simple automation.
Definitely. I think EnerVerse really signifies the shift towards robots that have a deeper understanding of their tasks.
Hmm.
Like you said, moving beyond simply executing, pre-programmed motions.
Yeah, this concept of robots understanding the why behind their actions
Yeah.
is really intriguing. What are the broader implications of this shift?
Well, I mean, imagine robots that can anticipate human needs, adapt to dynamic environments, and even suggest solutions
Wow.
based on their ability to predict future scenarios.
Yeah, it paints a picture of a future where humans and robots work together seamlessly, leveraging each other's strengths. And the researchers highlight some potential real-world applications.
Yeah.
What areas do they focus on?
Well, they talk about the potential impact on industries like logistics and warehousing,
Right.
where robots already play a significant role.
Right.
EnerVerse could enable robots to navigate those complex environments more efficiently, optimizing the flow of goods and minimizing delays.
Yeah, it seems like a natural fit for those industries,
Yeah.
streamlining processes and improving overall efficiency.
Exactly.
What other areas stand out?
Manufacturing is another one
Okay.
that could benefit significantly. EnerVerse could lead to robots that can adapt to variations in materials,
Okay.
handle delicate tasks with greater precision, and even learn new processes by observing human experts.
We often hear concerns about robots replacing human jobs.
Right.
How does EnerVerse factor into this conversation?
Well, I think it's important to remember that technological advancements often lead to the creation of new roles and opportunities.
Right.
EnerVerse could free up human workers from these repetitive or dangerous tasks,
Yeah.
allowing them to focus on more creative and fulfilling aspects of their work.
So it's not about replacing humans. It's about augmenting their capabilities,
Exactly.
expanding the possibilities of what we can achieve together. This has been a fascinating exploration of EnerVerse, this framework that seems poised to reshape our relationship with robots.
Definitely. And I think this research offers us a glimpse into a future where robots are not just tools, but collaborative partners,
Yeah.
working alongside humans to solve these complex challenges and create new possibilities.
That's a future I'm excited to witness.
Me too.
Well, for our listener, if you want to delve deeper into EnerVerse, we encourage you to check out the project page. And until next time, keep exploring the ever-evolving world of technology.